Welcome back, students. In the previous lecture we discussed about superposition theorem and its application in finding out the current through different resistors when we consider different voltage sources separately at a time. So today one more important theorem we are going to discuss, which is known as Thevenin theorem. So just like the superposition theorem, Thevenin theorem is also an important theorem in electronics, where it is used to simplify a complicated network of different components, and it is easy, simplifies the circuits, and it's lots of applications, theoretically as well as practical. But before we start discussing Thevenin theorem, let us discuss one more example of superposition theorem. As you can see on this screen, this is a circuit, and we are asked that using superposition principle or theorem, we have to find out current flowing through this resistor R3. Okay, 1 second. Okay, so this question was asked in 2019 examination of Kuba University. So this is important, and also I request you to please go through different examples, different numerical problems, because we have almost covered everything. So now it's your turn to try different questions, and if you don't know the answers, you can directly message me the question. So this question was asked by one student whose name is Bhavna Rawat. So I also request you all to please send me such questions, but before sending, you also try. First you try. If you are stuck somewhere, then you can send me. Okay, so I will cover those questions, those solutions here in this class. So let us see what is the question. So in this last lecture we discussed one application such similar to this question, but here the geometry or the circuit is different, so it may be difficult for you. So there is, you can see, two voltage sources, 20 volt and 36 volt. These R1 is 4 ohm, R2 is 12 ohm, R3 is 12 ohm. Three resistors, two sources. So we will consider one source at a time and calculate the currents. And remember here that only we have to find out the current through this resistor R3, this R3. So what we will start, first step is step 1. If I write here, step 1. So this is step 1, where first I will consider only this 20 volt source. So what we will then, because internal resistance is not given, so we will take it 0. Internal resistance of the source we will replace, and so this will be short. So I can redraw this circuit when this 36 volt is removed by its internal resistance, which is 0. So we can draw this circuit like 20 volt, and this is 4 ohm, this is R1. Okay, after this we have one resistance R3 going here and one resistance R2, because it is now short, so I can redraw this like this. Because this circle, sometimes voltage sources can be represented by this, and sometimes like this, positive and negative. So this is nothing but this. This is 20 volt. Okay, this is familiar. You are familiar with this symbol, or this circle is representing like this negative. Generally negative means this is grounded, so, or earth. So this is this symbol is like this, that this is connected to this negative terminal. So this is not something to be confused about. So this is not difficult. So I can write here this is grounded, this is also grounded. So this R1 is 4 ohm, R3 is 12 ohm, this is R3 12 ohm. This is again second R2, this is now short. So this is R2 is 12 ohm. So now this situation is like this. When we consider only one voltage source. So let us find out the current. So current direction I can point out from here. This is IR1. We can say this is IR1. This is IR3. This is IR2. So IR1 will be, so first resistance, total resistance will be R dash, let us write this, R dash will be total resistance of the circuit will be as seen from this voltage source, 4 ohm, then in the series parallel combination of these two. So 4 plus 12 parallel 12, okay, which will be 4 plus 6, which will be 10. So R dash will be 10 ohm, okay, it should be clear to you. Total resistance we have calculated. Now total current. So total current will be total current I will be 20 divided by 10, which will be 2 ampere. So this is I here, this I, or this I is nothing but the current flowing through this R1. So we can write IR1 will be 2 ampere and IR2, because here we have two similar resistors of the same value 12 ohm, so current will be divided equally. IR2 equal to 1 ampere as well as IR3 will be 1 ampere. This is first set of values. Now we calculate second set, means step 2. When we remove this 20 volt source and consider this 36 volt. So what will be the situation? Similar to the previous one. So this will be 36 volt. This is short circuited and 36 12 ohm. This is R2. Now R3 12 ohm and R1 is 4 ohm. This is the situation in step 2. So similar to the previous one, let us start finding out the current. So current will be flowing in this direction from this and here like this. Here also we have marked. So what will be the total resistance? Total resistance will be RT, we can also write as in the subscript T, but it is understood. You can write accordingly and as per your convenience. So R will be, total resistance will be 12 plus this 12 plus this parallel combination in the series of this 12. So 12 plus 12 parallel 4 like this, okay. So this will be 12 plus 12 and parallel 4, what will become the final value? 12 into 4 divided by 12 plus 4. So it's 48 by 16 means 3. So it is 15 ohm. Always keep in mind that you should not forget the values of this dimension, okay. Okay, so now R is in 15 ohm. And now let us find out the current. So total current I coming from this will be 36 divided by 15 ohm, which will be 2.4 ampere. So this is the unit is in ampere, okay. So this I is nothing but the I flowing through this R2. So I is IR2. IR2 is 2.4. So we can also write IR3 and IR1. So IR3 will be flowing through this resistor will be 4 divided by 12 plus 4, into total current coming through these combination. So total current is 2.4. So this is how current is divided into a parallel combination of resistors. 4 by 16, 1 by 4 means 0.6 ampere. And IR1 will be, you can do either way. One way is to directly subtract from the total current 1.8, or 12 by 16 into 2.4 will be 1.8 ampere. So this is again one set. Now we have to find the algebraic sum of these current, because algebraic sum is important, because here you can also see the current direction, current flowing through this R3. We are asked to find out current flowing through only the R3, but let us find out from all the resistors. So you can see from R3 current is flowing through only both times in the same direction, in the downward direction. One way is here and one direction is here, and final direction is here. Okay, these are positive, so current is direction is here, coming from here, and final current is coming from downward. So let us see how current is flowing through the R1 in both the steps. In R1, first positive to negative, okay, so it is 2 ampere, and in second step R1 is going from here, this is negative terminal, so this is opposite. So current flowing through this R1 will be IR1 dash minus IR1 double dash, which will be 2 ampere minus 1.8, so will be 2 minus 1.8 will be 0.2 ampere. Current flowing through the R2 will be, again these are in opposite direction, so IR2, okay, now double in this step 2 the current is flowing in the actual direction, so IR2 double dash minus IR2 dash, it will be 2.4 minus 1, so it will be 1.4 ampere. And now our real answer, the final answer, which is current flowing through this R3, will be IR3 is equal to, because current is flowing in the same direction in both these steps, so this will be added, IR3 prime plus IR3 double prime equal to 1 and 0.6, 1 plus 0.6 will be 1.6 ampere. So this is the final answer. However, these are also necessary to find out, because in the question say sometimes all the currents can be asked, so you should know how to find out the algebraic sum using the superposition theorem. So this is all about the application, and try to practice different questions, and also now it's time to discuss Thevenin theorem.